day before the election, a telephone poll of 350 randomly registered voters was conducted. And this is how it came out. 112 out of 350 were Brown, 207 out of 350 were Feliz, and 31 hadn't decided. This is a study. You know it's a study if you aren't controlling some factor, okay? If the people are naturally going to do that anyway. Okay, if I'm controlling the caffeine that you're intaking, now it is an experiment. You really need to go back and look at those notes. All right, so you need to go back and look at that. You need to go back and look at the different types of sampling, stratified, right? Put everybody in a group that's the same, and then take a simple random inside. Cluster is just reaching into the population and grabbing a handful. You need to go back and look at those things, okay? So when it says describe the population, it's not describe how you sampled, it's just who's the population that we're trying to understand, the 9,500 registered voters, okay? So it's pretty much the number of the population if you know, and who that is. So if I wanted to know what was going on with Hillcrest, all Hillcrest students would be my population, and then my sample might be this class. Now that would be an unrepresentative sample because most of you are seniors, okay, and you're high performing, but it's still a sample. All right, what is the size of the population? 9,500. Describe the sample, 350 randomly selected voters. And the sample size was 350. Then the sample statistic is that out of our 350, 112 wanted Brown. So then it says, if this was a representative sample, if we think 32% of the sample want Brown, then we're going to say, oh, that's probably the same for everybody. So 32% of the whole population want Brown. That's how they do polling for the president. They say, who do you want? And then they say, okay, well, that's what the whole state wants or the whole country wants. Okay. Explain what representative means. It matches the population. If I wanted to take a representative sample of Hillcrest students, I need a nice mix of freshmen, juniors, seniors, sophomores, all levels of performing, and even like socioeconomic, all of that stuff needs to match as much as possible. And identify one possible source of bias in a survey. Go back and read these and study them. Okay, this is non-response. Not everyone will answer a telephone poll. So you call them and say, hey, will you take this poll? And they say something not so nice and hang up. Okay? Remember, response bias is when you're pushing them to answer a different way. So if I said to you guys right in your face, who's your favorite math teacher? You're more likely to say me, whether it's true or not, because I'm there staring at you. That's response bias. Non-response is I give you the survey and you say, nah, and you hand it back. Okay? And then sampling bias is I just sampled seniors. Some way I took my sample, made it non-representative. Okay. So now we have, suppose students were asked how many times per week they eat in the food court. Okay? So what we're saying is that 4 students said they eat 0 times. They bring their food, they go sit in the hall, or they go out to eat. 7 students says they do it once a week, etc. This is listed like this because I don't want to have to list all the separate numbers. Relative frequency would be the percent, and cumulative relative would be adding them up. So the first one was 4. The next one is 4 plus 7 is 11. 11 plus another 6 is 17. And then cumulative relative is the percent of those added up numbers. Okay? Cumulative should add up to the total number of kids surveyed, and cumulative relative should add up to 100% of the population or the sample. You could get the data for these things by putting it in your calculator. Now, I highly suggest you find the similar one in the review too and do this. You are losing a little bit by not getting to try to do this on your own and ask questions. But when I gave too much time in class last time, you lost more. So we really need to go over it. If I wanted to do this in the calculator, if I wanted the average, I could add up all the zeros, all the ones, all the twos, all the threes, or I can do stat, calculate, one variable stats. My data is in list 1. My frequency was in list 2. And lo and behold, there's my average. There's my standard deviation, and there's my other standard deviation. One is for samples and one is for population, and we'll talk about that in just a second. And if you push down, there's your minimum, Q1, Q2, Q3, and max. You definitely wouldn't want to do the limiter method I'm going to show you in a little bit with this type of data, because there's so many numbers it would kind of suck. So that'll give you a much smaller amount of numbers if they ask you to do that. Okay, so I think we need to talk about class intervals. If you're talking about a histogram, class intervals means how many bars do you want? Okay, and bin widths are how wide are those bars? Remember on the Tootsie Pop project, which some of you need to show me today? You got to pick your bin width and it changed the shape of the histogram. Okay, so a lot of people had questions on this one in class yesterday. It says 4 class intervals, and they tried to do it between 0 and 7, because that's the numbers I have. But first off, it has to be a number line at the bottom. And this is the number, these are the numbers 0 up to, but not including 2. So in our discrete data, zeros and ones. This would be 2 up to 3.99999999999. In other words, the numbers 2 and 3. From here to here is 4 and 5, and from here to here is 6 and 7. And then you say, okay, how many numbers how many zeros and ones did we have? I had 4 plus 7, I had 11 zeros and ones. How many 2s and 3s did I have? 6 plus 3, I had 9 2s and 3s. You need to know how to read one of these charts. If you saw one of these charts, you should be able to say, oh, the bin width or the class width is 2. That's the width. How many numbers would be in each group? Questions? Now, for time's sake, I may not leave this up long enough for you to get all of it, so feel free to pull out your phone and snap a picture and or go back and watch the video, because I definitely want to get through all of the content. Those of you in the back are welcome to pull the screen down. All right, so next, I just showed you how to do one variable stats. And there's my min, my Q1, my median, my Q3, and my max. And I could have found that by listing all the numbers in the row and finding the number in the middle, and then the number in the middle of the bottom half, and the number in the middle of the top half. Okay, but you can use your calculator. Remember, IQR is Q3 minus Q1. You guys did really well with this stuff after the Tootsie Pop stuff, but then you've forgotten it all because we've been working with normal and probability. Next is the box plot. Okay, I don't think they're going to have you make a box plot because it's an electronic test, but they sure as heck will have you read one. Remember that 25% of the data is in each corner or each area, quadrant. And the length is just how spread apart that data is. Are they numbers next to each other on the number line? Or is it a 10 and 100? So the line between them is far apart. Okay, and you would want to check for outliers using these formulas just like we did on the Tootsie Pop lab. And in this case, there are no outliers, so it's not a modified box plot. Yes. Right here. Yep. I do think that this test is doable for all of you if you get your homework done. Okay? All right, next. Suppose we choose a random sample of 5 students from a survey, okay, and number 2. So now it's a sample. And these are the number of times they eat in the lunchroom counts. Find the mean. Well, that's add them all up and divide by 5, so it is 2. Or, in your calculator, remember mean is x bar. It's also the expected value for later on. They're synonymous. Standard deviation are S of x and sigma of x. This one comes with this formula, the square root of the sum of every value minus the average squared divided by n minus 1. And this one is the sum of every value minus the population average squared divided by n. You should know how to do it by hand, but I'm completely fine if you do it in the calculator. However, if you had by hand work and you had the right answer and then you messed up when you put it in the calculator, I could go back and fix it for you. Here's how you would do this one by hand. Every value. So 0 minus my average squared plus 2 minus my average squared plus 2 minus my average squared plus 2 minus my average squared plus 4 minus my average squared. Whatever that number is, and you get that number, then you divide it by the total number of numbers. N is 1, 2, 3, 4, 5. 5 minus 1 is 4. Once you've divided it, take the square root. I wouldn't try to put the whole thing in your calculator. You can, but I was talking to a student yesterday and she'd done it like 6 times and it wouldn't work. But when she broke it up, it did. Okay? Questions? Yes? Instead of 5? Because, so if it's a sample, because I said this was a sample of all the data, if you had done this with all of the numbers in that chart, all the zeros, all the ones, then it'd be 5. The reason they want you to subtract 1 is this measures how varied the data is, okay? If it's a sample based off the true population, it could be a little wrong. There could be more variation. You want to say that there's more variation because your sample could be a little higher or a little low. So if you subtract 1 from the bottom, by making your divisor smaller, the number you divide into with it, your answer will always be just a little bit bigger. So it's forcing this one to come up a little bit bigger than this one every time. So that you can account for the fact that maybe you made an error when you took your sample. Okay. Again, I don't know what it is up to you, but it is on video. You're welcome to go. All right, so there's that. Okay, explain what it means for two events to be independent. The outcome of one does not affect the probability of the outcome of another, right? George coming late to school is not going to affect Sally coming late to school, unless maybe they're siblings or boyfriend and girlfriend or something, and him being late, he's picking her up, and so now she's late, okay? It's with replacement or without replacement. The chance of me getting a heart out of a deck of cards is 1 out of 4. The chance of me getting a heart again is 1 out of 4 if I put my first heart back. But if I don't put my first heart back, then it's slightly less chance the next time. So that second one was dependent on what I got the first time. Okay. So if we draw one card from a standard deck of cards, hold it, and then draw another, are the two draws independent? No, based off of what I just said. And it's funny because I hadn't even looked at the review. It's just the standard way to talk about it. I literally have not looked at this question yet. Find the probability of drawing two consecutive hearts in the manner described. Do you guys agree with what I've got going on right here? What's the probability of getting a heart? It's not 4 out of 52. How many hearts are in a deck? 13. This would be the probability of maybe drawing a 6, because there are 4 6s. So let's change that. The heart would have been 13 out of 52 times 12 out of 51. That would have been the probability of getting a heart and a heart is the probability of getting heart 1 times the probability of getting heart 2 given already got heart 1. I don't think you need that specific type of writing, but it doesn't hurt to say that. So this one would actually be drawing just a specific number, something like a 6. This one was dependent on that one. Okay. Mutually exclusive means they cannot happen at the same time. I reach in a deck of cards, and I get a black heart. There are no black hearts. It's either a heart or it's black, right? Can't be both. Hearts are red. Another word for this is disjoint. Okay. In the experiment of drawing one card from a standard deck of playing cards are the events, this is hysterical, mutually exclusive. Again, I had not looked down at this problem when I made up that last example. No, because I can get a face card that is a heart, right? Half of the face cards are hearts, or not half, 1/4 of the face cards are hearts. All right, this one, the probability of A or B, probability of getting a heart or a face card. So you can draw a Venn diagram, or you can use the addition formula. This is where you're lucky that you get notes. Because if you've taken good notes, I bet you could almost find one example of everything on the test in your notes. And if you haven't, I don't know what to tell you. except for that every lecture for the last 2 units is online. Boring, but it's there. Okay, so probability of a heart is 13 out of 52, right? There are 13 hearts. The probability of a face card, there are 12 face cards. A face card being Jack, Queen, King, and Ace, and there are 4 suits. I like that back. Ace doesn't count, and there are 4 suits, so there are 12 of them. Okay, there are 12 of them, and 3 of them are the hearts. Jack of hearts, Queen of hearts, King of hearts. But if you just added up the red and purple values, you would have double counted the middle. So you need to subtract that to get the true value. Could you have just looked at the picture and said 10 plus 3 plus 9? Sure, you don't have to use the formula if it's not required. Don't make your life harder than it has to be. Use the way that makes sense to you. Questions? I know this is fast, but I want to give you everything I can. Okay, I'm going to move on. If you need to snack a picture, do it. I will also post the answer key. I didn't tell you that, so you can stop worrying about snapping a picture, actually. Okay, so now this, if this was my test, I would make you do one of those stupid virus problems, both in the tree and the chart. I'm sure they're going to ask you about one. Again, I don't really study their tests too much because then I give away too much, and I've gotten in trouble with that with Slick. So I just did a quick glance, okay? They're like, don't tell them what's on the test. Well, so I can't guarantee because I really do a quick glance. But this is what my test would have had on it. And that's where this came from. This came from their old finals. So here's the deal. Suppose a rare disease affects 1 in 500 people. So immediately you have disease or not disease. So 1 out of 500 have it, and 499 out of 500 don't. Hopefully this will help you on your homework because there are like a zillion of these on your homework. Okay. The diagnostic test used to detect the disease is 95%. Is positive 95% of the time if someone has the disease. That's a typo. So hey, look, you have the disease. So 95% of the time it tells you yes, you are positive for the disease, which means 5% of the time it tells you no. They lie to you. That's a false negative. Okay, and positive 10% of the time if someone does not have the disease. Okay, not the disease. And 10% of the time that's a false positive. Okay, we have this issue with COVID tests, especially the rapid ones. They have definite false negatives. They don't have a lot of false positives, but they have false negatives. But at least it's a data point. As a matter of fact, if you do a rapid test in a doctor's office and you get a negative, they say, okay, you're negative, but then they will follow it up, usually. Here, we're not doing that. We don't have the ability to do that, okay? So now, I don't really care about all of this, but what this is just telling you the branches. So, having the disease and getting a positive, you just times these two. Having the disease and getting a negative, disease and not positive is timesing those two. It's just going down the branches. Not having COVID and getting a positive versus not having COVID and getting the correct answer, which is that you don't have COVID. Okay? Really, you don't need to do that to do the homework. You just need to find the ones you need for the homework. You could also answer the same question with a chart. Now, before I do the chart, I'm going to answer one of these questions below, which is, oh, I hate it when it does that now. What is the probability of B? There are two ways to get to B. This way and this way of positive. So if they want the probability of B, it's this and this, or this and this. So you say up, up, positive, and I got a, I have the disease and I got a positive, and means multiply, or I don't have the disease, but I still got a positive. So it's, this is disease and positive, or not disease and positive. That is how you would use the chart for that. Then I also want to look at V, probability of having the disease given you got a positive test. So your test was correct. Well, you need to memorize this formula, but no, wait, you don't, because you get open notes, you lucky little suckers. Okay? It gave me heartburn for like a month when I found this out. And then I asked, I said, do I have to let them use notes on the test? And they said no. And then I've been nice. Okay, so A and B, again, that's A and B all over B. A and B, or not A and B. So it's using the answers from above. Now I know that for those of you who haven't done this yet, this is still confusing. For those of you that I've shown you this, and this is your 7th time seeing it, it's finally clicking. So I will take a question if you need it. Yes, dear. So what you have to, it'll never say that you have the disease if it's a word problem, because that always has to be one of the things they give you. What it will say is find the probability that you have the disease given you got a positive test or a negative test. And so you always think about it as, if I said find the probability that you got a negative test, the thing they say that you are, or that you have, find the probability that you have the disease given you had a negative test. The thing we already know about you is that you got a negative test. The thing we're sure of goes right here. Being that your test said it was negative, what's the chance that you actually have the disease? So this is the probability they're looking for based off of this previous information that we already know. So just try to pick apart their sentence. What part of they already know about this person for sure, and then the probability that we're trying to guess goes in the front. Anything else? Yes. So, ooh, yeah, so given and, which is multiply, or, which is add. Yep. Okay, so now let's make a table. Okay, so for the table, we say something like, okay, make it out of 10,000. Just do 10,000 every time, you should be good. Okay, otherwise you get decimals and it's just uglier. We know that 1 out of 500 have the disease, so I did 10,000 times 1 out of 500 to get that 20 people have the disease. If 20 people have the disease, then 9,980 do not. Now we're going to talk conditional. Of these poor people that have the disease, how many of them would get an accurate test? So you go back up to the story problem. Positive 90% of the time if you have the disease. That's an accurate test. So of these 20 people, what's 95% of that? 19. Which means then one didn't. Okay? They had the disease, but it told them you aren't sick. And then they went out there and spread it to everybody. I hate how relevant these problems are now. Like before it was this vague idea, and now we're all sitting here in these stupid suffocating masks, staring at people when they accidentally clear their throat. Sorry, I'm so over it. I can't. All right. And then we need to find one more. Okay, so this one was able to give us both of these. This one was able to give us both of these. And then the other one, 10% of the time if they don't have the disease. So 10% of this was the 998. That's why false positive and negatives are so weird. Depending on the test, it could end up being a large number of people still. And then you fill out the chart. Once you have the chart, most of you are pretty good about getting the answers. But remember, if it says given, this becomes your new denominator. Okay? Find the probability of A given B. Given you had a positive test. So I do not know why. This makes me feel like this is not the right answer. Let's check this. Okay. And this is how you put it in your calculator. I would do the numerator and then divide the denominator, but if you do it, 1 divided by 500 times 0.95 divided by 1 divided by 500 times 0.95, or you don't have the disease, but you still got a positive test. Sorry, it's really hard to type on this thing. If you do it just like this, you won't have an issue with order of operations. You can do extra parentheses and stuff, but this will work for you. Okay, yeah. So point, this is not the right answer, it's point. Oh, 1, 8, 7. For if I round properly. Okay, so let's use, yes, sir. It's whatever the computer asks for. I don't care. So you just have to watch and see if they put that little % on the side or what they asked for. And then now let's use, this is how I knew it was wrong. I could immediately tell that this was wrong because you only use this bottom number if it's like the probability of virus or the probability of positive. The minute there's a given, my denominator is going to change to that given. Think about this being a fraction on its side, and this just becomes the denominator amount. So, given you got a positive, B, 1017 over, you actually had the disease. So it is much easier to find the answer from the table, but the table I think is harder to make, so you pick what you want. And notice, we got the same answer. Questions? Yes? No, because the top of it is always disease and positive, so it's just this, what's in this box. So it still actually fits the formula, the probability of A and B, well, this is box A and B, all over box just B. Okay. So I'll let you guys look at the rest of these. If you see errors, let me know. Well, obviously, there are some errors as we're going through this. All right. So here's quickly. A friend devises a game that is played by rolling a single six-sided die once. If you roll a 6, he pays you $3. If you roll a 5, he pays you nothing. I normally do this box in the middle, right? I normally do X, situ, and probability. Doesn't matter. But always start with the situation. The situation is, I got a 6, I got a 5, or I got something less than 5. Because that's the easiest thing to think about. I won the lottery, I didn't win the lottery. I won the raffle, I didn't win the raffle. I got in a car accident, I didn't get in a car accident. I'll shut up. And then think about the probability, because that's the next easiest thing. There's a 1 in 6 chance of getting a 6, a 1 in 6 chance of getting a 5, and a 4 in 6 chance, there are 4 other numbers smaller than 5. 1, 2, 3, 4. The last part, this is the part you have to really think about when they're talking money games. Are you talking profit or straight wins? Okay. Are you looking at from kids' point of view or North's point of view? So you have to look at whose point of view it is. Okay. Find the expected value of the game, and this is in terms of the player. So they're not saying you don't have to pay anything to play the game. They're making it easy. You just get to play. So if you win, you get $3. If you get a 6. If you get a 5, you had the fun of playing. But if you get anything else, you get to pay the person $1. So this one is in terms of you playing. Now we want the expected value. The formula for that is the sum of every value times the chance of it happening. Again, you could put this in list 1 and this in list 2 and do 1 var stats list 1, list 2, and that would do it for you. Or first value, oh, sorry, mine is always that first column. The situation is my middle, so that's why I got confused. Excuse me. There we go. 3 is what you got, right? Money-wise, we're talking about money times the chance of it happening. So the value times the chance of it happening plus the next value times the chance of it happening plus the next value times the chance of it happening. And it's a negative 0.16. So on average, you'd expect to lose 17 cents. If you played the game once, you would expect to lose $1. There's a 4 out of 6 chance you're going to lose the $1. But if you played this game 100 times and you added up all your wins and losses and found your average, you'd end up averaging out to lose 17 cents a game. You shouldn't play this game. Okay? All right, so that's what this is saying here. Okay? All right, so now I'm going to talk about that one other thing. Now, there are Z-score questions that you need to study, but we just talked about that last time. So instead, I'm going to go to review 2. And I want you to go to the page that has this 15.2 on it. Okay, So suppose you recorded the time in seconds it took to solve a puzzle. All right, now what I'm going to do is I decided to, instead of having it in the chart, I decided to make it in a row because from smallest to greatest. And so this was my first number, my second number, my third number, fourth, fifth, sixth, seventh, and eighth. That's all I did was reorder it. Put it in order, least to greatest. Find the mean. You can do that later. Find the standard deviation. You can do that later. Okay? Here's the locator method. We would normally, let's try it, put it in our calculator. Actually, let's do it by hand. Our normal method would be our mean is halfway between these two. I'm just going to tell you. Then halfway between these two and halfway between these two. Turns out, using the locator method, because we have even numbers this time, I think we're going to get the same answers. But if you have an odd set of numbers, it's not as good. Okay, so let me show you. Here's the locator method. Write this down. It is also in your book. At the beginning of every module, it says learning resources, and you click on it. It has a full textbook. Okay? I just haven't forced you to read it because with what time? But feel free to go back and read that. Okay, here's the locator method. Find the minimum. Well, that's easy. The smallest number is 15.2. Locator method for quartile 1 is 0.25% of n. 0.25 because it's the 25th percentile, the first quarter. That is your locator. That's not your answer, that's your locator. Now here are the two rules. The first rule is if your locator is a whole number, use that number, use the number between it and the next one. So the squiggly blue writing says, if your locator number is a whole number, use the number between it and the next one. I would write this down verbatim because there's nowhere else in your notes it's at, and you are not allowed to use your book on the test. It specifically says. All right, so here's how you do it. It says find the lower quartile. Well, I have 8 numbers, right? So 0.25 times 8 is 2. 2 is not a decimal, it is a whole number. So I'm going to want to find the average of 2 and the number that's one above it. So if my locator number is 2, this is 2 and this is, and it should say here, should say something like L plus 1, like 1 up, okay? That's my locator number. So I'm going to find the average between those two numbers. Isn't that what we would have done anyway? So it really doesn't change if your numbers are even. 18.8 plus 19.3 divided by 2 is 1905. That is my first quartile, and that's probably what I would have gotten out of my calculator. However, I would show the work in case I'm able to give you partial credit. Now find the median. You could probably guess then that the locator for the median is 0.5 times n. 0.5 times n. And then since I got a whole number, I'm going to add up number 4 and 5 and divide by 2. If I had a different example, I would have done a different example on this one so that you could see the odd, but I'll show you. All right, and I will tell you, you would get, I don't know, see if I can erase that enough to, without, I don't know, somebody put that in the calculator, it's going away, whatever it was. Oh, there we go. So again, what we found was the number between 4 and 5, which looked based off our old way would have been the right answer anyway. Q1, Q2. Okay, you could probably guess then for quartile 3 at 75%, 3/4 is 75 cents. And you would do the same thing. And you would get the same answer that you would have probably gotten out of your, well, I shouldn't say probably, that you would have gotten out of your calculator. And you should not be surprised with the maximum. It's the maximum. This next part that I have covered up is the part that's going to be different. Okay? It's the part that's going to be different, or it could have been different anyway if you had odd numbers. The odd numbers are where it happens. If you had 9 data points or 3 data points. So, if the locator is a decimal, round up and use just that number. So there's, you round up and just use that number. And I just, when I glanced at the test yesterday, it said, P.S. use the locator method in your book. And I was like, and honestly, I really think they did that because either they want to make sure kids are reading the book or it was already made in that program and they didn't want to have to make a new one. So here's an example of that. What if I had these numbers? Okay. Their n is 5. My median is 10. That would be our old median, right? Here's the deal. Our old median would have been 10, the number right in the middle. Using this locator method, though, half of 5, because there are 5 numbers, 0.5 of 5 is 2.5. Says round that up, and it said use the third number. So it's telling me that my Q2 is 12. That's the difference. Okay, yes. I mean, oh, yes, it's 10. Sorry, it's 10, yes. It does make a difference on some of the problems, I swear. Specifically the one I saw on the test. I was wondering, I was like, that's really not the middle, but whatever they want. Okay, so in this case, it works for us as well. Okay, so I absolutely know, though, that I did one on the test, and it made a difference. So that's it. I will post the key to all of your thing online. Know that the one key for exam 2 might have some errors. I'm going to look. It's an old key from Slick. So if you don't like something that it says, let me know. I'll try to glance through it and make sure it doesn't. So again, correction. And if anybody in A-Day asks, let them know, because I told them for sure that the test was due Sunday. I am making it Tuesday. It's my Christmas gift to you. Don't waste the time. Use this weekend to get all the homework done. If you're ready to go, take it tomorrow. Opens in the morning. Like I'll set it to open like tomorrow morning. Like I don't know if it's like a 12 a.m. or something, but it might already have an opening time on it that you can go in and look. I don't know. Promise me you will show work and turn it in with your name on it. Okay. You guys feel a little better, yes or no? All right.